Welcome to Unshielded, the podcast where we explore the cutting edge of blockchain, data protection, and the quest for a more equitable and accessible internet. Today, we have a special guest who needs no introduction in the blockchain community, Charles Hoskinson, founder of Cardano and a key figure in the development of blockchain technology. In this episode, we're going to give you the origin story of Midnight, a groundbreaking project aimed at enhancing data protection in the blockchain space. We'll explore the challenges of transparency in Web3, how previous generations of blockchains can't keep a secret, and why projects like Midnight are needed to unlock wider adoption of decentralized technology. Charles, welcome to Unshielded. How are you doing today?
It's great to be here, Anthony. How you been?
I've been very well. I'm very excited to kick off a new podcast, a new focus. I'm very excited to have the audience understand and see more about Midnight and what we're doing, what we're building, and to be able to build out in the open through sessions like this. So thank you so much for joining us. For those people who don't know you, Charles, you've had an impressive journey in the blockchain space, founding several significant projects, Ethereum, Cardano, and now Midnight. What sparked your interest in blockchain, and how has your vision for the future of blockchain evolved in the last few years?
Well, everybody enters this industry kind of with some form of burning philosophy, if they're here philosophically. And for me, it was really a desire for sound money and institutions I could trust. You know, I kind of grew up as a political firebrand. I was a Ron Paul guy. I liked gold-backed money. And those were because I had an implicit distrust in the efficacy and integrity of institutions, whether that be the Federal Reserve or the IRS or whatever agency it happened to be. I noticed there was this reoccurring trend of, well, we promise we'll do better next time, and next time never comes. And they just keep being corrupt or lying or some issue like the 2008 banking crisis or, you know, the failure in Afghanistan or whatever. My generation is kind of the generation where we saw promises made, promises broken. And so we said, well, can we use technology to try to move from don't be evil to can't be evil by design? It's kind of like nuclear reactors. You know, like the latest generations of nuclear reactors, they're built in a way where if they get close to a meltdown, they shut themselves down by the laws of physics. So you go from a human is going to do the right thing, or we've designed it appropriately, to physics gets in the way and it prevents a bad thing from happening. So the question is, can you do that with social institutions, whether that be a voting system, a money system, your privacy, the data economy? And what the great irony is, I came into the space very early on in 2011. And since I came in, the need for blockchain technology has only increased, not decreased. Like, how do you regulate AI and align it? You know, how do you globalize the economy? How do you deal with global warming? How do you deal with all these global scale problems that require people to coordinate, but the people don't trust each other at all, especially in a world that's multipolar, where China and Russia and the United States are not getting along? You're not going to go and sign some sort of magical treaty and then suddenly everybody has a kumbaya. You need something that kind of is transnational and private and permissionless that can substitute for the fact that humans are traditionally pretty bad at staying honest and getting along with each other in the long run.
I hear you. And we're here for Midnight. And so I want to try and get to some of the core tenets of Midnight is about data protection, about integrity, about also enabling compliance. At what point, what specific event or realization led you to the inception of Midnight?
So blockchains keep saying we want real world applications. We want real world assets like real estate, securities. We want intellectual property. You know, we want gold. We want businesses like DAOs to live on a blockchain. And it's kind of a funny notion because blockchains, the way that we grew up with in the olden days of blockchains, they're public transparent systems. So they are immutable and time-stamped and irreversible, and everybody can audit it. Everybody can see the same things. Well, the problem is every modern business requires a public side and a private side. Even McDonald's, they don't tell you how much money's in the cash register or how many hours Jim is working at the cash register. That's proprietary information to the business. So then how can we decentralize everything and get all the businesses on a blockchain if that would then mean that we can no longer keep secrets? And so for me, it was very important to have a system that could do that, but do that in a way that preserves and protects one's freedom of association, commerce, and expression, so that you can keep that high integrity blockchain ethics that we've all kind of gotten used to inside the space. So how do you put those two systems together? Because traditionally what we do as an industry is we say, oh, the private stuff will be off-chain. But if you need both, what that means is you've collapsed the entire system from a decentralized system to a centralized system with a gatekeeper. So it's decentralized until it isn't, and then you're completely at the mercy of a third-party actor. which is not what we signed up for. We signed up for a system that every component of it is decentralized, whether it be the privacy preserving components of it, or the components that do the computation, or the components that store, or the components that audit and provide immutability and irreversibility. So the problem is, though, that when we started first working on this back in 2016, the industry wasn't ready in terms of the technology. So it took quite a bit of time and lots of papers and a lot of very careful thought about how do you bring this to market in a way that's global scale. And that's been a huge challenge. And Midnight is our most sophisticated and advanced team in terms of their thinking, the technology stack, and ultimately how to bring this to as many blockchains as possible.
And along the way, were there any particular technological innovations or any particular research that was a trigger to say, oh, we can do this now. We can do transparent and shielded at the same time. We can change the way we develop protocols different to how we've done them up until now.
Yeah, there was a blending of technologies that had to be put together. And I'll kind of run through. Let me bring up my whiteboard.
The famous whiteboard. That's what we're all here for. This is a core tenet of this show, and what we intend to do with Unshielded as we go forward is we want to show, not tell. We want to demonstrate as much as possible, and here it is.
All right, can you see my whiteboard?
I can.
Okay, so we got Midnight. I wrote Midnight there, a little test. So you asked about some core technologies, and the reason why it's super hard to build something like Midnight is you're really trying to reconcile three different payloads at the same time. So the first one is this concept of identity. And you need some way of merging identity and transactions together. So we have in the cryptocurrency space this concept of a DID, and that stands for a decentralized identifier. And so basically the idea is that you have this thing that you can tether with a transaction, or you can tether that with a wallet or some form of an account associated with a person. And then what you can do is you can build into that a concept of a disclosure regime. And so a disclosure regime is basically how you transmit identity information about the context of that transaction or that account to a person that's asking. So the canonical example that we like to use is, if you go to a bar in the United States and you buy some alcohol, usually you have to prove to the bartender that you're at or over the age of 21. And how we traditionally do that is that we'll go ahead and have something like a driver's license, and then we'll show that to the bartender, and the bartender will say, hey, okay, yeah, you're 36. Okay, check. But do they just know that you're 36? No, they know all this other information about you. They know where you live, and they know your exact age, and they know your phone number or whatever else is on that driver's license, depending upon the state. Some cases, I think they even put social security numbers on them, if you're an organ donor, all this type of stuff. And all you're really trying to prove is a yes-no statement. Are you at or over the age of 21? Yes? No. You see, and there's so many things in life where we do this part, but actually we should do this part, where we actually just ask a game of 21 questions. So the industry came together in 2013, and they started a 10-year journey to create the DID, the decentralized identifier, and a companion piece of technology called AnonCreds. And basically these two things together give you the ability to start putting identity into the system, which is unlinkable, which means that they're privacy preserving. So on the outside, people don't know who it is. However, you have a proof system where you can actually prove arbitrary statements. And so, are you at or over the age of 21? Or you could prove statements, for example, like, are you a Reg D exempt U.S. investor? So you're a credit investor. Are you a U.S. citizen or under U.S. jurisdiction? Is this post-tax money that we're dealing with? Are you on an OFAC list? I mean, basically anything that you can describe as a yes-no question, there's a regime where you can combine these technologies like AnonCreds and DIDs together. So we created a framework called Atala Prism, and basically that is an open multi-blockchain system that's now a Hyperledger project, and that was one of the first pillars. But that alone is not enough. Second, you also kind of need this idea of private smart contracts. So, as I mentioned, businesses, they have a hard time keeping a secret in the blockchain industry. So when you write a smart contract, the state of that smart contract, so state plus data, all those things that are interesting to it, when you interface with it, are public. So all the holders, all the money that's encumbered there, if it's a DEX, the trading book, all these types of things. But regulatory regimes and privacy really do require the ability to have kind of two sides, a public state and a private state. And the issue is that in doing this at scale with a distributed system is a super, super difficult thing. And there wasn't a really clear framework for it. So what we did is we actually invented a new technology called Kachina. And we wrote this paper back in 2020. And you can see it's a very long paper. It's 88 pages long. And there's a ton of cool things. But Midnight basically figured out how to implement this and build it in such a way where you actually had a turnkey model where you, as a developer, can segregate out and say what side of your contracts are public and what sides are private and how to manage that private state, and do that in a way where you could write it in TypeScript. So TypeScript is like JavaScript, basically. So from the developer's perspective, they can write a single smart contract and they just do some stuff and it's all built in. But then that smart contract can kind of sort out what's public, what's private. And then when you layer that primitive with a DID, then you have a disclosure regime. And when you put those two things together, you actually could, for the first time ever, start talking about real world assets. And you can talk about security tokens, and you can talk about intellectual property, and you can talk about a whole bunch of different things that are right now super difficult to actually put onto a blockchain, and you can automate the entire regulatory regime. But there's kind of a third part to it as well. And that third part is this concept of multi-resource consensus. MRC. And so we wrote a paper called Minotaur, and I think this is probably the coolest of everything we've done. You know, private smart contracts are super hard because you have to do all this weird ass snark stuff, and there's all these amazing technologies here. And identity is super interesting because we typically call this SSI, but multi-resource consensus is something that we didn't even know was possible. So I was just in a space actually with Mario and his guys, and there's thousands of people there, and we were having a debate of proof of work versus proof of stake. You know, so this is kind of the control mechanism for your cryptocurrency. So how blocks are made. Well, what if you could take your peanut butter and your jelly and put them together, and you could have a proof of work and a proof of stake system, or a proof of X plus, 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 plus. So you could arbitrarily many consensus algorithms together. Well, why is this important? Because here's the thing. Is this service something that's only useful to a small group of people? No, this is the future economy of all of crypto. So there's literally trillions of dollars of transactions and commerce that needs to be conducted here. And maybe, just maybe, Ethereum cares about that. And maybe, just maybe, Solana cares about that. And maybe, just maybe, Bitcoin cares about that. And maybe, just maybe, Cardano cares about that. Well, if you have a multi-resource consensus algorithm, that's got a proof of X here. And this has got a proof of X here, and this has got a proof of X here. So that's proof of work and Ouroboros, and that's Casper, and they have a proof of history here with Solana. Well, what you can do is you can actually chain together these things and other networks to maintain the state of kind of a layer 2 to everyone. And what this enables is this concept of a hybrid dApp. So this is, I think, the coolest thing, because one of the pillars of the third generation is interoperability. And how do we truly achieve interoperability? You create a consensus system where all the people around you have the ability to preserve and dial in and transact into your system. So there's going to be a dApp on Ethereum. Maybe it's an ERC20 token or something like that. And that dApp is then going to call into Midnight for a Kachina-based smart contract, do some private stuff and maybe some identity stuff. So maybe that's Uniswap sitting on Ethereum. And this is going to handle the US customers they come in, because there's now going to be a disclosure regime to say that they're allowed to participate, as an example. Well, that's a transaction into Midnight. And so what Minotaur allows you to do is it's one of the frameworks that allows observation and security to come from these different systems. And there's a collection and constellation of other technology that comes together. And so when you have this, then you can start being a layer 2 to everyone and serve everyone. And then all these systems can actually start using Midnight as if it's local. And that means there's no movement of the network effect. You don't have to migrate from Ethereum to Midnight in order to use Midnight. You don't have to migrate from Bitcoin in order to use it. So this effectively creates that whole nice internet of blockchains, a service-oriented internet of blockchains. And that, I think, is the coolest part of where Midnight is going. This privacy stuff is incredibly complicated. Confidentiality is a deep and rich topic, and there's so many things going on here, and there's tons of magic cryptography. My company's written 210 papers. We're pretty good at writing papers these days. And, the identity side is super, super interesting. But this idea of creating kind of a universal consensus algorithm that over time, years to decades, can link hundreds of different systems together. And every time you do it, you improve the base security of that system. And then in the process of doing that, it gives you the ability to offer services to that system and for people to actually dial in and use it for the private side of their business is a super, super powerful thing. And you end up getting exactly what you want, which is decentralization. But at the same time, you get the ability to put a regulatory regime on your dApp. And this is at the dApp level, not the protocol level. So the protocol basically treats everything fair. And then the dApp level, you get to decide, well, what does my regime look like? So you can imagine a business, and your business might be a DAO, and you could say something like, okay, well, HR and the CEO, the HR and the CEO, these guys get to see everything. Whereas, sorry, let me unplug something real quick. Didn't have enough water inside my hydro green, so it was starting to scream at me. So maybe the CTO can't see the HR records and can't see the personnel records of these types of things. So a disclosure regime basically would sort out who gets to see which data where, and that's an essential component for every business, every regulatory regime, even your own household. Maybe you don't want the kids being able to see your bank account or something like that, but you want to pay them allowance, on a weekly basis or a monthly basis or, something like that. So this is kind of the core of all of it. That whole idea of blockchains should be able to keep a secret. And the crux of it is that you shouldn't want to force the blockchain to leave its network effect. You want the dApps of every blockchain to be able, through very easy to use APIs and other methods, to kind of call into a system and then do that in a way that's oriented towards a web-oriented model. So you use TypeScript in this particular case. And in the process of doing that, this allows you to bring the trillions of dollars of real-world assets and activities into the blockchain space.
Brilliant introduction, Charles. Thank you very much. Lovely to see the whiteboard out as usual. You mentioned blockchains not being able to keep a secret. And I think previous generations of blockchain technology were renowned for transparency, renowned for re-engineering the way that we trust between individuals and organizations. But there are limitations, right? We still haven't seen as much widespread adoption of blockchains as we might up till this point, much more widespread adoption of dApps. And a lot of that comes down to what you described as the ability to have privacy and transparency together at a protocol level. Could you illustrate for those people who maybe don't understand previous generations of blockchains or protocols as much as you do, where does that fall down?
Well, the problem is that you have to be able to verify the things in the system. So the magic of a blockchain system is that you have a genesis block and an algorithm to change the system over time. And the big issue is that everybody has to be able to verify that the things that are happening are legitimate. So by nature, blockchains have to be transparent systems, because how can you check the work if you can't see the work? So you have to invent some sort of super powerful cryptography. In this case, it's called zero knowledge cryptography. And it's just like that proof that you're 21 or over. You get a yes, no for it. You can prove that some data is legitimate without revealing the data. So these techniques, they've been around since the 1980s, but the blockchain industry is the first industry to really take it and make it its own. And they're kind of building this whole universe of things where you prove that something exists without revealing it. You prove that something's legitimate and audited and without actually seeing the underlying thing. And that's super hard to do. And there's very few companies in the world except for input output and a few others, that really have the skill sets necessary to do this, because there weren't very many people who studied this particular topic of zero knowledge cryptography. Before the blockchain industry came in, there were probably about 500 to 1,000 cryptographers in the entire world who were authoring papers in zero knowledge cryptography. So it was a very specialized, very bespoke field. And then suddenly we came around the blockchain space and we said, I want to have an election where I can count my vote and verify that it was counted correctly and the integrity of the voting system, but not reveal my vote publicly. Okay, well, we can do that. It's called a zero knowledge proof. But gosh, how do you do it? And oh man, it's one thing to know from a paper and theoretically how to do it versus actually write the code and deploy and implement the system. And the issue is, if you screw it up, you can have catastrophic failure because you don't have transparency globally. So you can't just see some data and check it yourself. If there's a problem in the proving system, you might be able to forge a proof or something like that. And there's been some very famous bugs throughout the history of our industry for this type of stuff. So this is one of the barriers and why most blockchain systems have not adopted this technology. The other thing is, until recently, the performance and scalability just wasn't there. It takes so much excess computation to obfuscate and build these proofs that when you look at a global scale system with millions to billions of people, computationally speaking, it's not going to scale to be able to do that. And only recently have we developed next generation protocols that have the ability to graph these things on. And so it's kind of a combination of specialized skills and technology, a combination of inadequate protocols, and a combination of computational inefficiency that prevented this from coming into our industry. And then the other side of it is, how do you actually get people to adopt it and decentralize it? Most people have chosen the approach of, I'm building yet another blockchain, and everybody, if they migrate to me, that's the only way this thing is going to work. And the reality is, it's like, okay, there's 30,000 of these damn blockchains. Probably if you're entering a space where you have to conquer everybody's network effect, it's not going to take off. Because even if you have great technology, at some point the incumbents will find a way to adopt it. And since they have the network effect, they can't be there. So you got to look at it much more like the AI industry, where you don't want to compete with OpenAI or Google or these other big vendors. You want to be, if you're building a lightweight application, using them as APIs in your backend and these types of things, because they're evolving very rapidly and they have all these great capabilities. And Midnight's seeking to kind of do that. It's building this universal piece of infrastructure, and it doesn't particularly care who's calling into it. The point is to be a service layer for everybody so that they can actually get computational privacy and identity and other components so they can embed that in their business logic. And this is going to be so useful. You look at the MiCA framework and how it's trying to regulate DeFi in Europe, or what's happening in the United States with FIT or these other regulatory actions. There is going to be a merger of identity and blockchain. It has to happen. And if we want it to happen with integrity and principles, you need computational privacy. Otherwise, you're basically handing all your personally identifiable information to like your choice of 7 different banks, and you hope maybe, just maybe, that they give you permission to actually use your wallet. That's not compatible with the ethics we all signed up for as an industry. We really want an industry that preserves and protects the right of the individuals and prevents people from being, their data from being misused. Companies have been historically very bad custodians of these types of things. If you look at the OPM hack or Equifax or any of these things, they're just not so good at that stuff. And so you would much rather want to have high integrity systems that can't be evil and they have a predictable logic, but at the same time, they can allow you to apply, as a dApp builder, any regulatory regime you so choose for you and your customers.
And some of the protocols that we've seen so far have fallen a little bit short in being able to deliver that because of the way they were designed, or we assume today that when we transact through blockchains, we are pseudonymous, therefore we can't be tracked and traced. That's not really the case because we have the challenge with metadata and the production of metadata on certain chains. Could you dig into that a little bit for us? Because I think it's important that people realize the correlation of metadata being something of a challenge for enterprises and even for individuals.
Yeah, and you also have to understand that transactions have 5 components to them. And so first there's the transactions body, and it has the assets. So what are we transacting? And then second, it's not just assets moving, it's assets moving between actors. So there's people involved. or companies. So it's one to one, one to many to one, many to many, but there's some notion of people. And then third, you have metadata. So that's the who, what, when, where, why. There's a world of difference when you're withdrawing money from an ATM and you're at the Renaissance Festival versus the red light district. It's the same amount of money, but maybe there's a different intention with the money, right? And then fourth, there's a contractual understanding. What are you buying with it? What are you doing with it? Is it a donation to your favorite not-for-profit? Or is it a commercial transaction where they're supposed to mow your lawn for $100 or something like that? So there's the contract. And then fifth, there's the jurisdictions. As you look at the assets, the intent, the contractual understanding, and the particular actors, there's always geographies involved. So is it the United States to Germany, US to US? Is it Japan to Korea? Whatever have you. The problem is that in a global world, when you decompose this, it's becoming too expensive and difficult to actually be able to sort out regulation. So, I can construct a transaction in Bitcoin or Cardano that goes to every country in the world simultaneously. So I could transact where I create a wallet and I have addresses, and each one is owned by an national actor in a different place, as for Korea, South Korea, North Korea, China, Russia, Japan, go down the whole list, every country in the world, wallet address for each one. And that's one to many. So that one transaction is under the regulation of every country in the world at the same time, even though that regulation is contradictory. But unfortunately, that's what technology does. And regulatory regimes are not used to these types of things. They have these very well-defined pipes that exist between the different countries. And those pipes basically tell you the rules based on the asset and the actors, the amounts, and these types of things, how you move back and forth. So the only way you get out of it is algorithmic regulation. And you're absolutely right to point out that one of the most important components is metadata, because the nature of the assets, the metadata, and the governance of these things, they leak enormous amounts of personally identifiable information, and they leak enormous amounts about your commercial intent. And in many cases, that commercial intent is a trade secret. Look at ESG as a great example of that. So you have all these people running around the world saying we need to carbon score everything and we need to push ESG in the supply chains. Okay. But in the effort to measure the amount of carbon your business is producing, I can look at that, backward engineer from it, and figure out how many iPhones you're making. Or I can figure out what the oil supply is going to be next week, or these types of things, which would then give a commercial advantage to me while I trade on the markets, or as your competitor, know what your sales are going to look like before you announce them. You see, so you need to have privacy in these processes because, and it has to be ubiquitous, covering both the metadata and the data. But then you also want provability, because the people have to know: are you carbon neutral? The people have to know: is this fair trade? The people have to know: are you using cancer-causing dyes in your textiles, or these types of things? Or is that lithium ethically sourced, or did it come from a mine in Congo with a bunch of kids there? So you have to know these types of things to live in a modern economy. And if you go to any of the COPs or any of these big things, they don't have a solution for it yet. And also, even if they do, how do you get compliance? Because China has a standard, US has a standard, Russia has a standard. They're not quite getting along right now. Things are not so good geopolitically. So you need transnational standards for these types of things. So I tend to look at it from a transactional basis and say, what improvements are we making? And if you make improvements in the asset representation, the metadata representation, the transactional efficiency, and how the contracts work, then at some point you can actually get to a point where you have really good level of privacy that protects your proprietary business interests, your state secrets if you're a nation state, because maybe America doesn't want to reveal to Russia all the components it's buying as it ships them to Ukraine, or vice versa. It protects your sovereign interests as a company, as a country, and it protects it at a level with strong mathematical guarantees. But then, as I mentioned, you can put a regulatory regime, so you can still have an oversight mechanism that proves that the money's not being stolen, or proves that you're as an honest actor. I mean, nation states with clearance budgets are a great example. Like, how much money goes to the CIA in the United States? And they're not exactly going to give you a line item to the Congress of where they're spending the money. Not exactly, a line item you're going to get. But you can, with zero knowledge proofs and selective disclosure regimes, be able to prove that the money was not spent in certain ways that are counterproductive to the national policy, as an example. So what's so cool about this is that everybody benefits, from 85-year-old grandma who's trying to live in a password-free internet and doesn't want to get hacked but doesn't have a lot of technical skills, to a sovereign actor that's trying to do some geopolitics, to international companies, whether it be ExxonMobil or who's trying to adhere to ESG. And why blockchain? Well, it's got to be blockchain because there's no one actor who's trusted enough to centralize this, or else you've handed God mode to a single transnational body. And there's no one who should be given that right. We in the age of globalization, we kind of live well beyond that. And why Midnight? Because we're the first ones to really crack that hybrid dApp model and kind of imagine over the next 3, 5, 10 years of how you can build out a system that is a bridge between the legacy and the Web3 world and be interoperable with as many people as possible. And it doesn't require people to give up their network effect or give up their incumbent tokens or these things. That's the magic of what we've come up with. And that's why it took so long to do the research and so many papers had to be written, because it's actually a tremendously hard technical problem to be able to do that, but preserve these properties.
And I'm going to ask you to help contribute to taking all of that complex thinking, all of the research, and very many of those examples of why, and maybe distill it down, if we can jump back to the whiteboard, around how that works with a Midnight transaction. How do we have shielding and unshielding within a single dApp? Or how do we have the ability to have that work in a different way to, say, as it works on Cardano or Ethereum or any other blockchain today? Could you take us through a worked example?
Yeah, I can try. I mean, I don't want to get into the intricacies of zero knowledge cryptography, but let me.
Or at least at a process level, how do we go through? How do we go through kind of a traditional dApp working versus how do we get that same workflow, but with shielding and unshielding? Yeah,
exactly. Yeah. So it all begins with Groth circuits.
Tell me more about Groth.
Yeah, exactly. Okay,
and this is part of the challenge of blockchains to date, right? Is that people have explained them by how they work and the incredible technology that sits underneath them, and you lose the audience within the first 15 minutes, whereas you should have said, well, here's how it works today, and here's how it's broken. Here's how we can do it better.
Yeah, and so basically, as I mentioned before, transactions, they have those 5 components. And so for a transaction, you have assets, and then you have people, and then you have metadata, the who, what, when, where, why, how. And then you have, so assets, people, metadata, the contract, the contractual understanding. So the why am I moving this money around? And then typically you have some form of a regulatory regime. And those regulations can be nation states, or they can be internal policies or these types of things. So ordinarily in the blockchain space, most of our effort is spent here with assets. Okay. And we say, okay, and people usually is your accounting system. So in Bitcoin, we have a UTXO system. That basically means you have an input and an output. So you send from one address to another address. Ethereum has an accounts-based model, but it's just, I want to send it from Alice to Bob. That's what I want to do. So how the traditional systems give you privacy is this concept of pseudonymity. Pseudonymity is basically the idea is that you won't write the name Alice and Bob. Instead, you'll have address 1 and address 2. And your level of privacy inside that system is called the level of linkability. Okay? Your level of linkability. Now, if it was just Bitcoin and no one's ever used Bitcoin before and you're sending it from one address to another address, you'd have a low level of linkability. It'd be very, very hard to use that. But here's the thing. Nothing is ever forgotten in these blockchain systems. So if address 1 goes to address 2, goes to address 3, all the way to address N, well, what if you discover that one of these guys in the chain is an exchange? All right, and you know that's Coinbase as an example. Well, hang on a second here. If there's money coming out of Coinbase, Coinbase actually knows the lookup. And if that's the one right before this one, Coinbase actually probably knows the real world identity of this. So all I have to do is go and subpoena Coinbase and say, hey, give me all the records you have to that outflow. Oh, that's Bob over here. Okay, Bob, tell me why you got all that Bitcoin. You see, and so linkability can be added back in if you know something about your chain of transactions. And also you can examine the metadata from each of these types of transactions inside the system. And you can start looking at the geography. So where were these things transmitted? Or you can look at other patterns inside of it. And there's actually companies that this is what they do. It's called chainalysis, et cetera, et cetera. And that's okay if the intent is tax evasion detection and law enforcement and these types of things. But the problem is that not only just when looking at these things right here, with these global pseudonymous systems, do you leak a lot of personally identifiable information and privacy? When you actually go over here and you take a look at the contract side and the regulation side, almost all of these are totally transparent. So not only do you have usually a regime to be able to identify what the assets are and the people are and what they're doing and where they're doing it and how they're doing it, but then also with the contract and regulation side, you know exactly what they're doing. Okay, so it's not just, hey, I've sent 5 Bitcoin from Alice to Bob. It's, I sent 5 Bitcoin to a DEX like Uniswap, and I went and used it to buy some Litecoin or something like that. You know exactly where those funds were used and how they were used. And you don't just know them today, you know them forever. Okay, so 25 years from now, they know that you played a game of poker with Bob. And here's the problem. What happens if the social conventions change? And so the example I like to use for this is the nation of Iraq. Now, if you lived in Iraq in the 1980s or 90s or 70s, you had to be a member of the Ba'ath Party if you actually wanted to be a big guy, because it was a one-party rule. There's a single dictator, and that's that. So everybody in Iraq wanted to show and say, hey, I'm a good, loyal follower of the Ba'ath Party. Yay, you know. Okay, well, hang on a second here. After we invaded Iraq and took down the regime, if you were a member of the Ba'ath Party, you were excluded from public life. So everybody was trying to hide that they're a member of Ba'ath Party. And the same could be said with the denazification of Germany, or in Japan, going from Imperial Japan to modern Japan. You know, maybe your membership or participation in an activity today is okay, but 10 years, 20 years, 30 years down the road, it's not okay. Yeah, because changing standards in society. And it can go in a good direction, like in the case of the Ba'ath Party. It can go in a bad direction. For example, Afghanistan, when the Taliban took control again, if you worked with the United States as a translator or any other role, they'd shoot you in the back of the head if they found out that you were a translator for the U.S. So you're trying to hide that you had that membership, but the problem was the biometric database got leaked. So the Taliban was able to identify who the translators were, and yeah, they didn't do so well. So in general, it's a really good idea when you talk about contract and regulations and these types of things to be able to keep these things globally private.
And maybe to bring it down to a lower level, Charles, I mean, if you think about the dApps that we're using online, if you have in any way your wallet address compromised, that could just be, you know, your regular wallet. They know how much assets you have, right? Which dApps you've interacted with. Essentially, it's like making your browser history and your bank account public to everybody. And it might be Chainalysis is able to do that. It might be that somebody doxes you by mistake, or it may be something as simple as maybe you chose your first and second name as your .eth address. Right. Heaven forbid. And then connected that to your Facebook account, at which point now Mark Zuckerberg knows your bank account and your browsing history in Web3. And, you know, taking it down to that level, there's a very large number of people, I suspect, who are out there doing this, who believe they're operating under pseudonymity, right? Who probably don't understand the implications.
Exactly right. Or in the process of doing this, you leak a bunch of data and then they use it to train AI, and now the AI can steal your voice, as Scarlett Johansson has learned. Or, you know, the AI can steal your music, as Snoop Dogg is complaining about, or these types of things. So, you know, generally speaking, what you want is a system where your use of the system is globally private, meaning external actors can't know that, but you have some form of a disclosure regime capability. Because then what you can do is you can sit down in a negotiation with the stakeholders, whether they be regulators or oversight mechanisms for your contractual understanding. And you could say, okay, who gets to see what, where? And in the process, that's the only thing that they get to see. And we get a math-based guarantee of that. This is absolutely essential as world commerce becomes more global, because we live in an age where nothing is forgotten ever. if we lived in an age where things got thrown away every few years, we could at least argue, well, they only remember for a little while. But now, what you had for breakfast as a 12-year-old 25 years ago is probably known to somebody, which is a pretty amazing thing. And the problem is we can't predict how that's going to be used in 25 years or 50 years or 75 years or, these types of things, especially as the social stuff pings pongs back and forth. I grew up and Roe v. Wade was the law of the land. Now it's not. And what if some state passes a law and says that, abortion retroactively is illegal and anybody who got is a murderer or something like that? Well, the problem is if nothing is ever forgotten, that's pretty easy then to map people. So it's a human right when you think about saying, let's live in a world where globally speaking, it's private, but you have a disclosure regime, and really trying to figure out how to do this in the blockchain space is the crux of the project. And in terms of the technology, how do you do that? These things change over time. There's all kinds of things like the SNARKs is one, succinct, non-interactive arguments of knowledge. And then you have like this thing called Halo and a ... There's all these different frameworks and technologies, but really that's useless to people if you have to understand how that works. That's about as useful as programming if you have to understand how the microchip works and be able to write an assembly. And unfortunately, that's where the most of these privacy frameworks are at to the developer, is you have to have enough understanding of the mechanics of these systems that you actually have to, at the circuit level, basically be able to build in your privacy regime. What makes Midnight so special is it says, look, you're going to, as a contract and in a transaction, you're going to write up in using TypeScript, which is the language of the web, kind of what you want to do, and then the rest of that's going to get sorted out by the infrastructure, and then you're able to embed that, and you kind of build it into your application. And the app I always like going back to again and again because it really drives home is a DEX. And this is not hypothetical. Uniswap just got hit with the Wells notice, and a big chunk of regulatory concern is that when a DEX does something, it's really hard for the governments to know who's actually trading and exchanging. Exchanges are very well-regulated instruments. They have to get specialized licenses for a variety of reasons. So you have all this money that's going into a DEX, some stuff happens inside of it, and then you have all this money that goes out of a DEX, okay? And the problem is that outside of the security of that system, it's really hard to know where that money is coming from and where that money is going. And this is antithetical to about 100 years of regulations that we have with exchanges for people. So what regulators are doing is saying, well, if we don't know the inputs and the outputs, let's just kill the DEXs altogether. Let's just say they're illegal and shut them down completely. Instead, what you want to do is you want to build a system where settlement is compliance. So what does that mean? It means that if Alice is sending money into a DEX, what's going to happen is that the transaction is going to have a bunch of predicates with it, so proofs that she sends along. And they can even be built into the wallet. And those proofs basically allow her, when she sends those transactions into DEX, to prove to the system that she meets some sort of suitability guideline. And some of those things will be public data, and some of those things will be private data. For example, maybe she's a U.S. citizen, or the nature of the assets going in, or what have you. Okay, well, the network doesn't get to see the private part. What Midnight can do is it can kind of act as the disclosure engine and make sure that that stuff is put in a way where it's not globally available. Okay, so going back here, we say globally private. However, it has a disclosure regime built in. In this case, maybe she has a DID, and that DID went through KYC. All right, so we now have some proof, and maybe she's proven that that transaction is post-tax money, so it's not money laundering or something like that. Now, the DEX is a smart contract. There's no centralized actor. It just has a whitelisting thing saying, okay, well, you have to have these types of proofs, and those proofs have to be signed by the following set of agencies or whatever. But the minute that that settles in the DEX, it means it's fully regulated and everything's great. But it's still a completely decentralized application. And the instantiators of that DEX, they don't get any of that information. It actually exists somewhere else, and there's a wind-up for it. And when money goes out, it's the same situation. Okay? So what does this mean? It means that you can actually build a fully compliant DEX with algorithmic regulation and no loss of personally identifiable information private, because at the end of the day, these proofs are kind of automated and they're built into the wallet and all this stuff. From her experience, she's just sending a transaction like she used to send a transaction into Uniswap. And eventually, all of these things could be written into algorithms and libraries. And as an application developer, you just call them as an API. So you say, oh, this is a German user, pull the German library. Oh, this is a US user, pull the US library. And the smart contract knows how to sort all that stuff out. And then for the private side of that stuff, it calls an API to the Midnight network. And there's some smart contracts and applications people built on Midnight. And they basically sort all that stuff out. So I think that's something in 3 to 5 years we could see as a use case or a pattern. And a lot of jurisdictions are going to love this because basically it makes their job so much easier. Otherwise, you kind of have this chaos here and there's a constant tension because the legacy world says very clearly that this is illegal. You can't do this. But then we have this DeFi world, and the DeFi world is like, but we wanna, that's what they're saying. And so there's got to be kind of some sort of compromise. And the compromise really is saying, well, if I have a situation where you can prove using some sort of decentralized automated process that's censorship resistant, that you're not a bad actor using this system, and it doesn't leak your personally identifiable information, it's globally private, would you be willing to compromise there? And a lot of people would say yes. Some people would say no. And you know what? That creates a marketplace for the settlement as compliance, because this is not at the protocol level. This is at the dApp level. So some people would be very comfortable, especially with regulated commerce like security tokens marketplaces. Let's say you're issuing NFTs as a user, and your NFTs have royalties built into them. Okay, so every time somebody buys that NFT, you get 10%. And maybe you want to securitize those royalties and sell tokens representing that royalty stream. And every time somebody buys your music, your fans get 10% of the profit or something like that, giving them an incentive to spread your music. Well, that's a security token under most regimes. Well, security tokens need broker dealers and they need disclosures and there's suitability guidelines and all this type of stuff. Well, what if you could automate that entire process and make it turnkey in a template and you're fine? Well, what if you're selling in a completely unregulated product, like a meme coin or something like that, and there's none of that stuff? Well, you don't need a disclosure regime. And there's no restrictions on the settlement of these types of things in most established jurisdictions. So what happens is you have a framework that on a dApp by dApp process, you can build that, and it takes care of that magic moon math, all this Halo stuff and Snark stuff and these types of things, and allows you to really focus in on what are the assets you're trading, how are the people doing business with each other, what metadata is public versus private, and then ultimately, how do I write a contract where all this stuff can kind of get automated. And then eventually on the regulatory side, you can just wire that in as basically an API call to a library. That's the world that I think can bridge those two gaps. And that's going to be the next Ethereum when you think about that.
And a lot of that complexity is obfuscated, right? Because the infrastructure, the APIs, the connectivity, the blockchain that sits underneath it, the calls, the user doesn't get to see any of that or doesn't necessarily need to see any of that. It's how the infrastructure runs. When you buy and sell stocks online, you don't see any of the settlement. You don't see any of the broker-dealer stuff. You just go on the website, you put in your credentials. Maybe there's an extra step in this case where you have to have your KYC credential that's been issued by a party of some kind. And you go through the flow. It's like maybe adding a second form of verification.
Yes, exactly right. And that's what makes it so valuable. If you can hide that from the user, then this is the first time ever that you actually can bring real life use cases and real world applications and real world assets into the cryptocurrency space. And they no longer look like crypto assets. They all look like just the next generation of assets. They become digital assets. And what's so cool is the code is law. That's the big difference between this and centralized private systems. In centralized private systems, you're completely at the mercy of what the hell people are doing with that stuff. Like OpenAI, when you go use ChatGPT, whatever you send them, you hope to God that they're using that with wisdom and judgment. And 25 years, they don't find out about your My Little Pony fetish or something like that. You just hope that they're being honest. With these types of systems, we don't hope. We know up front what are the terms and conditions. They can be audited and templated, and they're there, and they get more efficient over time. They get cheaper and easier to use over time, and eventually they get connected to more and more systems. Like CBDCs are a great example of this, where most people would be okay with a CBDC if they had a constitution. with the CBDC, meaning that you can't violate certain rights of people. Why we are so skeptical of CBDCs usually as society is we realize, hang on a second here, if I give the government a superpower of being able to freeze my money at any time or know what I'm buying and make arbitrary decisions of how much of that I get to consume, that's a dystopian world. If I'm standing at the gas pump and it says you've bought too much gasoline this week, you can't buy anymore. I don't want to live in that world. So the problem is there's no can't be evil in CBDC designs. And this is the point of technologies like Midnight, is that it tells you upfront exactly what can and can't be done. You know that on a DApp by DApp basis, and you create a marketplace for these types of things. And then the infrastructure takes care of that. And what it does is it says, as a developer, your level of complexity only needs to be the same level of complexity used to write web applications and websites and the stuff that millions of developers around the world are using. You don't have to be a PhD in cryptography and know all this magic moon math and know how these circuits work and these types of things, because those are commoditized. And those are, while complicated, they're going to change all the time, and latest innovations are going to come out. And, leave that to people who have PhDs in the topic and they argue over these fine details. You don't want to know where your electricity is generated from. You don't want to know how your car engine works. You don't want to have to be able to fix your electrical panel in your house. The vast majority of people can't do these things at scale. But that's okay. Modern society works because all that complexity is obfuscated. And that was kind of the magic of the iPhone. It took all this complexity that computing had and it changed it to an interface where you click a button and magically a map pops up and now you can navigate with it. And you click a button and magically a browser comes up and you can just find stuff and ask questions. That's what we look for as consumers. And that is where the mainstream is finally able and comfortable to enter into the cryptocurrency space.
A fantastic and hopefully relatable start to the Unshielded podcast. That concludes part 1 of our deep dive into the Midnight origin story with Charles. In our next episode, we will continue our conversation to discuss use cases that make Midnight a standout in the blockchain space. Make sure you tune in for part 2, where we'll also delve into the future steps for scaling Midnight in 2024 and interoperability with other blockchains, Cardano and beyond. And remember, if you've enjoyed this episode, please subscribe, rate, and leave a review. Your feedback helps us bring more insightful conversations and lets us improve the content for future episodes. So thank you for listening, and we'll see you in the next one. Unshielded is brought to you by Midnight. To find out more about how the Midnight Network is helping everyone to build a more equitable and accessible internet, visit our website at midnight.network. And remember to search Unshielded on Apple Podcasts, YouTube, Spotify, or wherever you get your podcasts. And be sure to subscribe so you'll never miss an episode.